underground runs outside of buildings must meet specific requirements. Firstly, they must be installed in a listed underground enclosure. Secondly, they can be encased in concrete at least 2 inches thick and provided with a top consisting of a 4-inch concrete slab or equivalent. Thirdly, they can be covered with at least 3 inches of earth or sand in lieu of earth on top of the cables. The concrete encasement of 2 inches thick is typically applied by pouring concrete on the floor of the trench, routing the cables, and then pouring concrete over the cables. A trough constructed in this manner, while not specifically listed, can provide equivalent protection to a listed underground enclosure, as described in NEC section 280.50. This section pertains to underground enclosures. Underground enclosures shall be listed for this purpose and shall be designed and installed to protect cables from damage. Section 280.50 addresses surge arresters. Surge arresters that are installed in enclosed locations shall be guarded against contact by unauthorized personnel. Metal enclosures containing surge arresters shall be grounded. Surge arresters shall be permitted to be located in a substation or switchgear room. The NEC addresses various aspects of wiring and protection. For example, Article 310 covers conductors for general wiring, specifying allowable ampacities, insulation types, and installation requirements. Article 300 covers general wiring methods, including requirements for protection against physical damage, proper support, and securement of cables and conductors. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. These articles provide detailed guidelines for ensuring safe and reliable electrical installations. Cable trays, which are mentioned in the question, are addressed in Article 392 of the NEC. Cable trays are typically used for supporting and routing cables in industrial and commercial applications, and the NEC specifies fill requirements to prevent overheating and ensure accessibility for maintenance and inspection. However, since the specific scenario involves an underground open-bottom concrete cable trough, the cable tray fill requirements may not be directly applicable. Instead, the focus should be on ensuring that the trough provides adequate physical protection and heat dissipation for the cables. While there isn't a specific fill area requirement for underground concrete cable troughs in the NEC, general principles of cable management and heat dissipation should be considered. Overfilling the trough can lead to overheating of the cables, especially if they are carrying significant current. The ampacity of conductors is covered in NEC section 310.15. The ampacity of a conductor is the maximum current in amps that the conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacities of conductors are provided in tables in Article 310, and these tables are based on specific conditions such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. Adjustment factors are applied to these ampacities to account for different conditions, such as higher ambient temperatures or more conductors in a raceway. These adjustment factors reduce the allowable ampacity of the conductors to prevent them from overheating. In an underground cable trough, it is important to consider the thermal environment and the potential for heat buildup. Factors that can affect the temperature of the cables include the depth of the trough, the type of soil surrounding the trough, and the amount of sunlight exposure. In situations where the cable trough is heavily loaded with cables, it may be necessary to provide additional ventilation or cooling to prevent overheating. The NEC provides guidelines for directing conductors based on the number of current-carrying conductors in a raceway or cable. These directing factors are applied to the ampacity of the conductors to reduce the allowable current-carrying capacity and prevent overheating. The directing factors are specified in NEC Table 310.15 colon. For example, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be directed according to the table. The directing factors vary depending on the number of conductors and the type of insulation. In addition to directing for the number of conductors, the NEC also requires directing for high ambient temperatures. If the ambient temperature exceeds 86 degrees Fahrenheit, the ampacity of the conductors must be derated according to NEC Table 310.15 Bone. The derating factors for high ambient temperatures vary depending on the type of insulation and the ambient temperature. When installing cables in an underground cable trough, it is important to ensure that the cables are properly supported and secured. The NEC requires that cables be supported and secured in a manner that prevents them from being damaged or subjected to excessive strain. Cables can be supported using cable ties, cable cleats, or other approved methods. The spacing between supports should be in accordance with the cable manufacturer's recommendations or the NEC requirements. In addition to supporting the cables, it is also important to protect them from physical damage. The NEC requires that cables be protected from physical damage by installing them in raceways, cable trays, or other approved methods. In an underground cable trough, the concrete encasement provides physical protection for the cables. However, it is still important to ensure that the cables are not subjected to excessive strain or abrasion. When installing cables in an underground cable trough, it is important to ensure that the cables are properly grounded. The NEC requires that all metal enclosures and equipment be grounded to provide a path for fault current to return to the source. Grounding helps to prevent electrical shock hazards and protect equipment from damage. Cables can be grounded by connecting them to a grounding electrode system, such as a ground rod or a metallic water pipe. The size of the grounding conductor should be in accordance with NEC Table 250.122. In addition to grounding the cables, it is also important to ensure that the cable trough itself is properly grounded. The NEC requires that all metal enclosures and equipment be grounded to provide a path for fault current to return to the source. The cable trough can be grounded by connecting it to a grounding electrode system, such as a ground rod or a metallic water pipe. The size of the grounding conductor should be in accordance with NEC Table 250.122. When installing cables in an underground cable trough, it is important to ensure that the cables are properly identified. The NEC requires that all cables be identified with their voltage, ampacity, and function. Cables can be identified using cable markers, cable tags, or other approved methods. The identification should be clear and legible and should be permanently affixed to the cable. In addition to identifying the cables, it is also important to ensure that the cable trough itself is properly identified. The NEC requires that all enclosures and equipment be identified with their function and voltage. The cable trough can be identified using a label or sign that is permanently fixed to the trough. The identification should be clear and legible and should indicate the purpose of the trough and the voltage of the cables it contains. When installing cables in an underground cable trough, it is important to ensure that the cables are properly spliced. The NEC requires that all splices be made in accordance with the manufacturer's instructions and that they be properly insulated and protected. Splices should be made using approved splicing methods, such as crimp connectors or heat shrink tubing. The splices should be located in accessible locations and should be protected from physical damage. In addition to splicing the cables, it is also important to ensure that the cable trough itself is properly maintained. The cable trough should be inspected regularly for damage or deterioration. Any damage should be repaired promptly to prevent further deterioration. The cable trough should also be kept clean and free of debris to prevent the buildup of moisture or contaminants. When working with electrical cables, it is important to follow all safety precautions. The NEC requires that all electrical work be performed by qualified personnel who are trained in electrical safety. Workers should wear appropriate personal protective equipment such as gloves, safety glasses, and hearing protection. Workers should also be aware of the potential hazards associated with electrical work and should take steps to minimize the risks. These steps include energizing circuits before working on them, using insulated tools, and avoiding contact with live parts. The NEC also requires that all electrical equipment be properly maintained and inspected regularly. This includes checking for loose connections, damaged insulation, and other potential hazards. Any problems should be corrected promptly to prevent electrical shock hazards or equipment failures. The NEC provides detailed guidelines for safe electrical work practices. It is important to follow these guidelines to ensure the safety of workers and the public. It's important to consult the latest edition of the NEC and local codes for specific requirements related to underground cable installations. The NEC is updated every 3 years, so it's crucial to stay current with the latest changes. Also, local codes may have additional requirements or restrictions that must be followed. Always consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable codes and standards. In summary, while the NEC doesn't explicitly define a fill area for open-bottom concrete cable troughs, considerations for heat dissipation, cable support, protection from physical damage, grounding, identification, and splicing are crucial. Furthermore, adhering to general wiring methods outlined in Article 300, conductor ampacity requirements in Article 310.15, and the principles of underground enclosures as per 280.15 ensures a safe and compliant installation. Always prioritize safety and consult with qualified professionals to guarantee adherence to all applicable codes and standards. When dealing with 600-volt power and control cables in an underground trough, remember to select cable types suitable for direct burial or wet locations as specified by the NEC. THWN, XHHW, or use-rated cables are commonly used for this purpose due to their moisture resistance and durability. Ensure proper cable spacing within the trough to facilitate heat dissipation. While there isn't a specific rule for trough fill, aim to avoid overcrowding the cables. A good practice is to maintain at least a cable diameter's worth of space between adjacent cables. This helps prevent excessive heat buildup, which can degrade insulation and reduce cable lifespan. When transitioning cables from the underground trough to above-ground equipment, use appropriate conduit and fittings to protect the cables from physical damage. Seal the conduit entry points to prevent water and debris from entering the trough or the equipment. Proper sealing minimizes the risk of corrosion and electrical faults. Periodically inspect the trough and cables for any signs of damage, such as cracks in the concrete, exposed conductors, or water accumulation. Promptly address any issues to maintain the integrity and safety of the installation. Keep the trough covers securely fastened to prevent unauthorized access and protect the cables from external factors. Use corrosion-resistant hardware for the covers and supports to ensure long-term durability in the underground environment. When adding or modifying cables in the trough, carefully plan the routing to avoid disturbing existing cables. Ensure that all new cables are properly supported, identified, and spliced according to NEC requirements. Document all cable installations, including cable types, sizes, and routing paths. This documentation is valuable for future maintenance, troubleshooting, and upgrades. Consider using cable management accessories such as cable ties or separators to organize the cables within the trough. This helps prevent tangling and makes it easier to identify and access individual cables. When backfilling around the trough, use compacted soil or sand to provide a stable base and prevent settling. Avoid using sharp rocks or debris that could damage the cables. Ensure that the backfill material is compatible with the cable insulation to prevent chemical degradation. Properly slope the trough to allow for drainage and prevent water accumulation. This helps minimize the risk of corrosion and electrical faults. Consider installing a sump pump in the trough if it is prone to flooding. The sump pump will automatically remove excess water and keep the cables dry. Consult with the qualified geotechnical engineer to assess the soil conditions and ensure that the trough is properly designed and installed to withstand the expected loads. The geotechnical engineer can also provide recommendations for backfill materials and drainage systems. When selecting cables for the installation, consider the ambient temperature and the potential for temperature fluctuations. Choose cables with a temperature rating that is appropriate for the expected conditions. Avoid exceeding the maximum operating temperature of the cables, as this can lead to premature failure. When performing maintenance or repairs in the cables, always de-energize the circuit and follow lockout-tagout procedures to prevent accidental energization. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical hazards. Be aware of the presence of other utilities in the area, such as gas lines, water lines, and communication cables. Contact the appropriate utility companies before digging or excavating near the trough. Use ground-penetrating radar or other methods to locate underground utilities before digging. Exercise caution when working near underground utilities to avoid damaging them or causing a hazardous situation. When installing the trough, ensure that it is properly aligned and level. This will prevent water from pooling in the trough and ensure that the covers fit properly. Use shims or other methods to adjust the elevation of the trough as needed. Consider using a precast concrete trough to simplify installation and ensure consistent quality. Precast troughs are manufactured in a controlled environment and can be installed quickly and easily. When connecting cables to equipment, use appropriate connectors and terminations. Ensure that the connectors are properly sized for the cable and that they are compatible with the equipment terminals. Follow the manufacturer's instructions for installing the connectors and terminations. Use a torque wrench to tighten the connectors to the specified torque. Avoid over-tightening or under-tightening the connectors, as this can lead to loose connections or damaged terminals. When installing control cables, consider using shielded cables to minimize interference from electromagnetic fields. Shielded cables have a metallic shield that surrounds the conductors and protects them from external noise. Ground the shield at one end of the cable to provide a path for the noise current to return to the source. When installing power cables, consider using cables with a low coefficient of friction to make it easier to pull them through the trough. Cables with a low coefficient of friction require less pulling force and are less likely to be damaged during installation. Use cable pulling lubricants to further reduce friction and prevent damage to the cables. When installing cables in cold weather, be aware that the insulation can become stiff and brittle. Warm the cables before installing them to make them more flexible and easier to handle. Avoid bending the cables sharply in cold weather, as this can damage the insulation. When installing cables in hot weather, be aware that the insulation can become soft and sticky. Store the cables in a cool, shaded area to prevent them from overheating. Avoid exposing the cables to direct sunlight, as this can damage the insulation. When installing cables near trees or shrubs, protect the cables from root damage. Use root barriers or other methods to prevent roots from growing into the trough and damaging the cables. Trim trees and shrubs regularly to prevent them from overhanging the trough. When installing cables near roads or sidewalks, protect the cables from vehicle traffic. Use reinforced concrete or other methods to protect the cables from being crushed or damaged by vehicles. Install warning signs to alert drivers to the presence of underground cables. When installing cables near bodies of water, protect the cables from water damage. Use waterproof cables or other methods to prevent water from entering the trough and damaging the cables. Install drainage systems to remove water from the trough. When installing cables near corrosive environments, protect the cables from corrosion. Use corrosion-resistant cables or other methods to prevent corrosion from damaging the cables. Apply protective coatings to the trough to prevent corrosion. When installing cables near hazardous materials, protect the cables from chemical damage. Use chemical-resistant cables or other methods to prevent chemicals from damaging the cables. Install containment systems to prevent chemicals from leaking into the trough. Remember that proper planning, installation, and maintenance are essential for ensuring the safety and reliability of underground cable systems. Always consult with qualified professionals and follow all applicable codes and standards.